This video will cover basic statistics, item analysis, and data interpretation, outlined in Chapter 6. Here is an example of the grading scale used in the UASA 24/25, showing the marks and corresponding notes for each grade. The learning outcomes for this chapter include analyzing grouped and ungrouped data, frequency distribution, and graphical representations like histograms and ogives. Basic statistics is a scientific method or a set of mathematical procedures for collecting, organizing, summarizing, presenting, and analyzing data. The stages of basic statistics include data collection, data presentation, data analysis, and data interpretation. Raw scores or raw data are collected randomly and are unorganized. They need to be organized and displayed systematically for accurate calculation and interpretation, often using frequency tables, polygons, ogives, or histograms. Here are the raw scores for 20 Year 4 Meller students in a mathematics test. The scores can be arranged in ascending order, from smallest to largest, as shown here. They can also be arranged in descending order, from largest to smallest. Frequency refers to the number of students who obtained a specific score. This table shows the score, frequency, percentage, and cumulative percentage. To construct a cumulative frequency table, the steps are: determine class data and class interval. Next, set class boundaries. Then, create tally marks. And finally, state the frequency and cumulative frequency. Grouped scores can be processed by grouping them into score groups called class intervals. The table shows class intervals, boundaries, tallies, frequency, and cumulative frequency. The histogram is a graphical representation of the frequency distribution using adjacent bars. The horizontal axis represents the score or mark, and the vertical axis represents the frequency. A frequency polygon is a line graph connecting the midpoints of the tops of the bars in a histogram. It illustrates the distribution shape. An ogive is a graph representing the cumulative frequency distribution. It helps estimate scores below a certain percentage or estimate the passing mark. A cumulative frequency distribution is represented by a curve called a cumulative frequency curve, or ogive. It is used to estimate percentile points and percentile ranks. The measures of central tendency are mode, mean, and median. The mode is the most frequent score in a set. In the example set, the mode is 30, appearing 3 times. The median is the middle score for an odd number of scores, or the average of the 2 middle scores for an even number of scores. Scores must first be arranged in ascending or descending order. For ungrouped scores, the mean is calculated by summing all scores and dividing by the number of scores. The formula is shown here, where $x$ is the mean, $sigma_x$ is the sum of individual scores, and $n$ is the number of scores. The mode is rarely used in student achievement assessment. The median often replaces the mean when there are extreme scores, as it is a more accurate representation of overall achievement in such cases. The formula for calculating the mean of grouped scores is $frac sigma fxn$, where $f$ is the frequency, $x$ is the class interval midpoint, and $n$ is the number of scores. This table illustrates the process of calculating the mean for grouped scores, including class intervals, frequency, class midpoints, $x$, and the product of frequency and midpoint, $fx$. Standard deviation is a measure of the spread of a set of scores. The formula for calculating the standard deviation of ungrouped scores is shown here. For grouped scores, the standard deviation formula is similar, but it uses the midpoint of each class interval instead of individual scores. The formula is displayed here. The value of the standard deviation indicates score variability. A large standard deviation means scores are widely spread or heterogeneous. A small standard deviation means scores are similar or homogeneous. If student scores are normally distributed, the graph is a bell-shaped normal curve, as shown in the image. In a normal distribution, the area under the curve represents all scores, with 50% above the mean. If scores are normally distributed, the mean, median, and mode values are equal. The graph should be produced every time test scores are plotted against frequency. Sometimes, a skewed normal graph results. If test questions are too easy, a negatively skewed graph results, where the mean is smallest and the mode is largest. If the test is too difficult, a positively skewed graph results, with the mode smallest and the mean largest. The image displays examples of a negatively skewed graph and a positively skewed graph, illustrating how the distribution of scores deviates from a normal curve. Standard scores are used to compare a student's position relative to other students. They show the student's position in terms of the number of standard deviations from the mean. The two common standard scores are $Z score and $T score. The formula for calculating the $Z score is shown here. A higher $Z score indicates better student achievement. The formula for calculating the $T score is shown here. The higher the $Z score value, the better the student's achievement. The $Z score involves decimal and negative values, while the $T score only involves positive whole numbers. This makes the $T score easier for teachers to read and interpret student scores. This is a model examination paper problem. Using standard scores or other methods, determine if Shafiq's achievement is better in Malay language or English language. Show all calculations. To compare Shafiq's performance, we first calculate the mean and standard deviation for both subjects. For the Malay language test, the mean is 29. The standard deviation for the Malay language test is calculated as the square root of 606 divided by 5, which results in 11.01. Next, we calculate the mean and standard deviation for the English language test. The mean for the English language is 21. The $Z score for Malay language is 0.09, and for English language is 0.40. Since Shafiq's English language $Z score is higher, his achievement is better in English language compared to Malay language. Discuss how teachers can use basic statistical analysis to understand and interpret student achievement test data that has been implemented.